Okay. Yeah, this is the most popular site in the Highland Reservoir. You can see that in my back, so the column had become the bended, like S shape. So in the middle, there's a dark colored rock that cut through the columnar joints. So how this could be formed? So as I mentioned, the columnar joints was formed 140 million years ago. When they cooled down, and before it's completely solidified, it's still in the plastic state, there was earthquake and ground movement. So the column actually buckled and tilted. So they become S-shaped. So the location, we see the black rock, actually there are the fractures generated during the bending process. So after 40 million years, around 100 million years ago, so a different rock intruded into this crack and formed this vertical dike, the D-Y-K-E. Apparently, there are two different kind of rocks. As I mentioned before, the volcanic tuff are made by the silica-rich minerals like feldspar and quartz. So they appear to be lighter colored with big crystals. While the intruded rock belongs to a different type, which is called basalt. It appears to be a dark, fine, igneous rock, which contains a lot of ferromagnesium minerals and less silicate minerals. So we call it felsic rock. So apparently, this intrusive rock was 40 million years younger than the parent rock. But if we look back to the site, we can see quite a lot of grasses actually already grow along this dike that indicated that the weathering process would be much easier on the basaltic rock than the volcanic rock. So it's a very direct evidence to prove the weathering resistance of these two types of rocks are quite different. Yeah. All right, side by side, I can put them together. Yeah, hold this. Yeah, this basaltic rock, this volcanic rock. This is felsic. This is acid. This contains large amount of ferromagnesium mineral. This contains less amount of ferromagnesium mineral, but contain a lot of silica minerals. All right, so it's a very interesting phenomena here. We can recognize these two rocks here from this site, and a very interesting stories on the back. So let's take a closer look, maybe closer to the site, to see the dike more closely. Either the basaltic dike actually is this basaltic dike. This is volcanic rock. So the dike actually goes through the crack and occupies the space. So in between these two rock units, actually there's the big zone here because of dike intrusion, the lava is quite hot. So there's a bit of thermal reaction over the interface. But clearly see a basaltic dike and volcanic rocks on the two sides. Most spectacular sites.